All right, welcome back. We dealt with aggregation a little bit, and the big piece that you hopefully got out of that video was that whenever you have a lot of samples, whether they're the same size samples or different size samples, you're going to do a weighted mean, and that's going to carry you forward to talk about the overall population. Even if you don't have all the population data, you can still get a pretty good estimate of the population data by getting the mean of all the samples that are out there already, or just as we'll see in the next chapter, so not right away, but we'll get to it, of just doing a big enough single sample. But let's do a weird example and just kind of get more familiar with how these samples work. So suppose that in America, every single household keeps either 3 or 8 or 11 rabbits. I just made those numbers up. Obviously, that's not reality, but it is now. And we'll suppose that it's evenly distributed. Every house either is 3 or 8 or 11, and exactly one third of all American households have exactly 3, exactly one third of all American households have exactly 8, and exactly one third of all American households have exactly 11 rabbits in that home. So, my first question to you, before we even talk about means or anything like that, or statistics or parameters, is simply this. This is a counting question. If we surveyed two random households, what different results could we attain? And I'll go ahead and tell you, settle this right up front, order matters here. We're going to call them, for a counting perspective, a different result. And I'll tell you why in a minute. But how many different results could we obtain? And if you want to go ahead and pause the video and think about it, go ahead and do that. And I'll see you in whenever you unpause the video. But for the rest of us, there are, well, for everyone at this point, there are 9 different outcomes. And we can use our counting formulas on this using the fact that order matters. There's a lot of households out there, so repetition is obviously allowed. There are exactly 2 selections we're making, and we've got 3 options per choice. That's going to come out to be 9 total outcomes. I went ahead and listed them out here. You could do 3 and 3. You can get 3 and then 8. Or you could get 8 and then 3. And I know for all practical purposes, that's the same result, but you could get it either way. In fact, in the same way that if you had 2 children, a boy then a girl is technically the same as a girl then a boy as far as gender is concerned, but I list them separately because when we take these possible results and turn them into probable results, we do see that some are more likely than others. Because you can get an 8 and a 3 or a 3 than an 8, you are twice as likely to get 3 and 8 in some order than you are to get 3 and 3. And that's going to be important. So here are all of our probabilities spelled out. Right, there are 9 total outcomes, but some of them double up from a probability standpoint. And now what I want us to do is start finding statistics based on these potential samples. So for instance, for the sample of 3 and then 3, what's the mean of that sample? What's the median of that sample? What's the range of that sample? What's the variance? What's the standard deviation? And actually, that was going to be pretty straightforward because actually there's 3 easy ones, right? I'll go ahead and do the hard part here, right? The mean of a sample of 3 and 3 is, well, 3, I guess, right? You take all your numbers, add them up, divide by the number of values you have, and you've got 3 as your mean. The middlemost number is also 3. The range is nothing because the minimum is the maximum. There is no variation. There is no variance. There is no standard deviation. So all that's pretty straightforward. Same for 8 and 8. Same for 11 and 11. Now, a little bit of arithmetic has to be done for the rest of them here. Right, for 3 and then 8, we add those up, divide by 2. We're going to get a mean of 5.5. Same for the median. It's halfway between those 2 numbers. And actually, we can then use Excel or the formula hard and fast to find the variances and the standard deviations. And so I'll pause here, let you transcribe this, let you soak this in. But these are all numbers that we can calculate based on the techniques and formulas and ideas we've covered so far. So we'll stop here, and then we'll start doing things with these statistics up next. See you then.